In this video, I'm going to go over how to balance chemical equations. All right, just a few things I want you to remember. That arrow is going to be dividing up the reactants and the products, okay? So the reactants are the things that go into the chemical reaction, and the products are what we get out of. The other thing I want to remind you is imagine a line right underneath that arrow. That's going to separate both sides, and of course our goal is what we have on the left side to equal what we have on the right side.
Okay, let's start off with a visual representation of my first example. So we have iron oxide and carbon combined to leave iron on its own and carbon dioxide. So to help you all imagine what's happening, I'm going to use these red chips to represent iron, blue to represent oxygen, and green to represent carbon. So right now, let's see, without balancing anything, what each of these compounds look like given the coefficient of 1. Okay, so if we take a look at our reactants and our products, here's our visual representation of what we've got so far. As we can see on this side, we've got 3 oxygens. This side, we've got 2. This side, we've got 2 irons. This side, 1. And our carbons actually are okay. Now, the goal of balancing chemical equations is we want the same thing on the left as the right. So that's going to involve us adding some more elements to make sure they're both balanced, which means we're going to need a number or a coefficient in front of each of the compounds to represent the fact that both sides are balanced. All right, okay, so to balance it, I'm going to start off with the irons. Now, often when balancing equations, you really want to leave the hydrogens and oxygens to the very end. That's really important for combustion reactions. In this case, I'm choosing to start off with the iron because I notice I've got 2 here and 1 here. So I'm going to add 1 iron, and because iron is on its own, it's not going to affect anything else going back and forth. So there's my iron. Now the next thing I'm going to move on to is my carbons, but carbons right now seem to be balanced. So we're good except for our oxygens, which again, we're now leaving to the end. So if I add my oxygen, based on the fact that it's carbon dioxide, I can only add 2 oxygens at a time, but I have to add a carbon because it's attached to that. So here's my 2 oxygens, but it's carbon dioxide, meaning it's actually attached to this carbon molecule here. All right, so now I have 1, 2, 3, 4 oxygens on this side and 3 on this side. So we're still not balanced. Not much else I can do on this side at the moment, except for maybe recognizing that I've got 3 here and 4 here, and we can think of our math or our multiples. What I'm gonna do though, actually, is I'm gonna go back to this side and add 3 more oxygens. So with the 3 oxygens adding, just like the carbon dioxide, I can't just add 3 oxygens on their own. I have to add the 2 irons. Okay, so that looks good. I like the fact that this is looking a little bit better. Now with my irons, we can see we've got 4 on this side and 2 on this side. So I'm just gonna go ahead and add a total of 4 irons. So looking at my left and my right, my reds are completely balanced. In other words, the iron is completely balanced. Now let's go back to the oxygens. By adding 2 additional irons, because they're attached to 3 oxygens each, we've got 6 oxygens on this side, but only 1, 2, 3, 4 on this side. That means I need to add 2 more. Well, the only way I can add 2 more oxygens is by adding a whole other carbon to it, meaning I'm adding another carbon dioxide. Okay, let's count everything. We know our irons are good, so that part's great. We've got 6 oxygens, so 6 oxygens here. What do we notice? Well, the only part that's not that's not balanced is the carbons. So we've got 1 on this side, 3 on this side, which means I need to add 2 more here. Okay, count it out for me. Does everything look balanced? All right, so yes, of course, everything is balanced. We can see it there. So now we need to add the coefficients or the number in front of the compounds to tell us how many molecules we've used of each one here. So starting with the iron oxide, I've got 1 molecule of F2 and 3 oxygens and another one right here. That means a 2 is going to go in front of that. With our carbons, we've got 1, 2, 3. So 3 are going to go in front of that. Iron, there's 4. We're going to put a 4 right there. For our carbon dioxide, we've got 1, 2, 3 carbon dioxide. So a 3 goes there, and now everything is balanced. Focusing on the top here, that is your answer for this chemical equation when it's fully balanced.
Okay, let me know in the comments if you like this visual representation of the chemical equation. If you do, I'm happy to make more.
Okay, let's look at our second example. So what I have here is I have a hydrocarbon, so hydrogen and carbon combined together with oxygen to make water and carbon dioxide. With this, anytime you see this sort of combination, so a certain number of hydrogens and carbons together with 2 oxygens, that's going to be a combustion reaction. We are burning propane here. Now, with balancing this type of reaction, I want you to follow the chocolate rule. Basically, this tells us the order of how we're going to balance everything. So we're going to start with balancing the carbons, the hydrogens, and then the oxygens. So I'm going to model that here with the little visual representation so you can see what's happening. So on this side, we can clearly see we have 3 carbons. On this side, we just have 1. So I'm going to add 2 carbons here. Now, normally I would say, okay, we know carbon is bonded to 2 oxygen each time, but let's think of our rules here. We want to balance the carbon, the hydrogens, and the oxygens. So let's take a look at my hydrogens. On this side, I've got 8. This side, I've got 2. So I'm going to need to add some more on the product side. So let's take a look at what that's going to be. So just focusing on the hydrogens, again, we're going to come to the oxygens after. And I'm going to add the hydrogens in pairs because for every 1 oxygen, I have 2 hydrogens, and I'm trying to get 8. So I've got 8 on this side now, and now I have 4. I'm going to need to add 2 more. Well, that gets me to almost what I want. 8 on this side, 6 on this side. Let's add 2 more. All right, perfect. That looks good. So our carbons are balanced, our hydrogens are balanced. Now let's look at our oxygens. Okay, so looking at the oxygens, the last one that's balanced, I've got 2 on this side and 3 on this side. So that's obviously not balanced. So first thing I'm going to do is I'm going to add 1 here. Now, keeping in mind where most students struggle with this is I have 2 compounds that have oxygen. So I know for every compound I added, I do have to add an oxygen, right? Because for every 2 hydrogen, there's an oxygen. Okay, so that leaves me with 1, 2, 3, 4 on this side, and 6 altogether on the product side. So I'm going to keep adding the oxygens just in the fact of how they are related to the molecule. Okay, so now let's take a look at it. We've got 2, 4, 6, 7, 8, 9, 10 oxygens on this side, but only 2 on this side. So we know I'm going to need to add 8 more to get to 10 on both sides. Okay, so what I did is I added the number of oxygens to make it balanced. Keeping in mind, I added each of them as a pair because oxygen is a diatomic molecule, which basically means when we write it as O2, every molecule has 2 oxygens in it. Okay, so now let's go ahead and let's count how many of the molecules we have. So for my propane, my 3 carbons and 8 hydrogens, I just have 1. So I've got 1 of those. That's good. For my oxygens, I've got 1, 2, 3, 4, 5 molecules, each containing 2 oxygens for a total of 10 oxygens balanced with the 10 on this side. How many waters do I have? 1, 2, 3, 4. So we're going to go ahead and put a 4 on that. And for my carbons, we can see that there's 3 there. Excuse me, my carbon dioxides. So we put a 3 there. And that is our balanced chemical equation.
All right, I hope that was helpful. In the description below, I've left you with a practice worksheet to help you go through what you've learned. And as always, I do hold those one-on-one sessions. Information for that can also be found below. Until then, good luck balancing equations, and I will see you all in the next one.